Welcome to the next session of theoretical distributions. Now, binomial distribution concepts we discussed in the last two classes. Now I am introducing Poisson distribution. Poisson distribution. Poisson distribution. Okay. First question is, when will I use Poisson distribution? Okay, and what are the properties of Poisson distribution? First point, it is a limiting case of binomial distribution. It is a limiting case of binomial distribution. And is applied under the following conditions. And is applied under the following conditions. Okay. N, the number of trials. The number of trials is indefinitely large. Is indefinitely large. That is, n approaches to infinity. The number of trials is indefinitely large. P, the probability constant of success. The probability constant of success for each trial is indefinitely small. Is indefinitely small, that is, P approaches to 0. Mean is equal to variance is equal to NP. This is equal to M. Is finite. Instead of M, you can use any letter here, K, lambda, anything as you like. So, mean is equal to variance is equal to NP. This is equal to M. So under these conditions, we use Poisson distribution instead of binomial distribution. Okay, next. Probability mass function. Probability mass function is given by P of x is equal to r e power minus m into m power r by r factorial, where r is taking the values 0, 1, 2, 3, etc. up to infinity. E power minus m into m power r divided by r factorial. This is the expression we are using for calculation of probabilities in case of Poisson distribution, where r is equal to 0, 1, 2, 3, etc. infinity. Okay, note down. Now, continuation of this, since the variable r is assuming only whole numbers from 0 to infinity. Since the variable r is assuming only whole numbers from 0 to infinity, comma, Poisson distribution is a discrete probability distribution. Poisson distribution is a discrete probability distribution. Next point. Poisson distribution is a uniparametric distribution. Uniparametric distribution. And the parameter is M. Poisson distribution is a uniparametric distribution and the parameter is M. Next, a linear combination of two Poisson variables. A linear combination of two Poisson variables is also a Poisson variable. A linear combination of two Poisson variables is also a Poisson variable. That is, x is a Poisson variable with a parameter m1. Y is a Poisson variable with a parameter m2. So x plus y is also a Poisson variable with parameters m1 plus m2. With parameters m1 plus m2. Next, mode of a Poisson distribution. Mode of a Poisson distribution. Poisson distribution may be unimodal or bimodal. Poisson distribution may be unimodal or bimodal depending on value of m. Poisson distribution may be unimodal or bimodal depending on the value of m. When m is an integer, it is bimodal. And the two modal values are k minus 1 comma k. When m is not an integer, then the distribution is unimodal, and mode is the integral part of m. Mode is the integral part of m. Mode is the integral part of m. Okay. Next point. When m approaches to infinity, Poisson distribution will become symmetrical. That is, Poisson distribution tends to normal distribution. Poisson distribution tends to normal distribution. So these are the points you have to keep in your mind when you are solving the problems of Poisson distribution. Okay, no doubt. Then I'll go to the problems. Look at the question number 9, page number 17.43, set B. If the standard deviation of a Poisson variate x is 2, then probability of 1.5 less than x, x less than 2.9 is question mark. Okay, this is the question I have. When I want to do the problems of Poisson distribution, I need the value of m, which is the parameter of the distribution. If I know the value of m, anything I can do in Poisson distribution. See the solutions are given. Standard deviation is equal to 2. So variance is equal to standard deviation square, this is 4. So this is 2 square, this is 4. For Poisson distribution, mean is equal to variance is equal to NP. This is equal to m is equal to finite. It is a finite number. So m is equal to 4 here. M is equal to 4. Now, e power minus m, e power minus 4, 1 by e power 4. E power minus 4 value generally given along with the question. In any case, e power minus 4 value is not given. Don't worry, we can calculate. E is equal to 2.7182, remember this value. E power 4. 2.7182 to the power 4. (2.7182) into 2.7182 into 54.5915. You put it in memory. 1 divided by MRC is equal to 0.0183. 0183. This value is 0.0183. Now, probability mass function e power minus m, m power r by r factorial, 0.0183, 4 to the power of r by r factorial, where r is taking the values 0, 1, 2, 3, 4 up to infinity. R will take only whole numbers. Now what is required for you? Probability of 1.5 less than x, x less than 2.9 is question mark. Look at this. This is r is equal to 1.5. This is 2.9. In between there is only one whole number. After 1.5 and before 2.9 there is only one whole number to we have. And we know Poisson distribution is a discrete probability distribution. Poisson distribution is a discrete probability distribution. Means it will take only whole numbers. It will take only whole numbers. So probability of 1.5 less than x, x less than 2.9 is probability of x equal to r is equal to 2. Factorial. 0.0183 into 16 divided by 2. 0.0183 into 8. 0.0183 into 8.1464. 0.1464. This is the answer to the given question. This is answer to the given question. Now look at the 10th question. If the mean of a Poisson variable x is 1, then what is probability of x greater than or equal to 1? This is my question. See the solution, sir. When I am doing a problem of Poisson distribution, then I will search the question for what? Mean value. If I know the mean value, I can do any type of calculation. So look at this. Given mean is equal to m, this is 1. E power minus m, e power minus 1, 1 by e, 1 by 2.7182. This is 1 divided by 2.7182, 0.36789, 0.36789. This is the value. This is the value. Now probability of x is equal to r. E power minus m, m power r by r factorial. This is the probability mass function for a binomial, for a Poisson distribution. So 0.36789 into 1 to the power of r by r factorial, where R is taking the values, R is taking the values 0, 1, 2, 3, 4, 5, 6 up to infinity. 0, 1, 2, 3, 4, 5 up to infinity. What is required for you? X is equal to R, this is greater than or equal to 1. This is greater than or equal to 1. Look at this. You have to take the calculations from 1 to infinity. R is greater than or equal to 1 means starting with 1. My calculations will go up to infinity, which is beyond my capacity or which is beyond the capacity of anyone to go up to infinity. So what will I do? 1 minus probability of R equal to 0. Probability of happening of an event is equal to 1 minus probability of not happening of an event. 1 minus 0.36789 into 1 power 0 by 0 factorial. So this is 1 minus 0.36789. 1 power 0 is 1 by 0 factorial is 1. So this is minus 1 is equal to 0.6321. 0.6321. This is the answer to the given question. This is question number 11. If x is a Poisson variable with parameter m and its coefficient of variation is 50, coefficient of variation is 50, what is the probability that x would assume only non-zero values? X would assume only non-zero values. This is my question. X is a Poisson variable and CV is given, coefficient of variation is given. Once again, it is a technique which is used for consistency of the data. Don't worry about here, about CV. Now see the solution. I want m value. CV is equal to standard deviation by mean into 100. This is the formula we have to use for calculation of CV. CV is equal to standard deviation divided by mean into 100. For Poisson distribution, mean is equal to variance, and variance can also be written as a standard deviation square. For a Poisson distribution, mean is equal to variance. Variance can also be written as standard deviation whole square. So 50 into standard deviation is equal to 100. Standard deviation is 100 divided by 50, this is 2. So variance is equal to 4. Variance is equal to 4. Variance is equal to 4. For a Poisson distribution, mean is equal to variance is equal to m. This is 4. E power minus 4 is 0.0183. 0.0183. P of x is equal to r. This is 0.0183. 4 to the power of r by r factorial, where r is taking values 0, 1, 2, 3, 4 up to infinity. Where r is taking the values from 0 to infinity. What is required, sir? It will take non-zero values. Non-zero values means 1 to infinity. We cannot do the calculations because it is going up to infinity. So 1 minus probability of r equal to 0. 1 minus 0.0183. 4 power 0 by 0 factorial. 1 minus 0.0183. 1 minus 0.0183. This is 0.9817. 9817. This is the answer. Okay. Question number 12. If 1.5% of items produced by a manufacturing units are known to be defective, what is the probability that a sample of 200 items would contain no defective item? Okay. So P is equal to probability of happening of an event. Happening of an event. This is 1.5%. Defective item. 1.5% of items produced by a manufacturing unit are known to be defective. N is equal to size of the sample. This is 200. This way it is given. Probability of x equal to r is equal to 0 question mark. Probability of x equal to r equal to 0 question mark. Now, as sample size is 200, I am going for Poisson distribution. Okay, generally when the value of n is less than or equal to 50, we use binomial distribution. Again I am saying generally, it is not a rule. When the value of n is greater than or equal to 100, we use Poisson distribution. Okay, here n is equal to 200, so I am using Poisson distribution. So when you want to use Poisson distribution, what is required for you? M value is required. So m is equal to np. 1.5 by 100 into 200. I'll write 200 first. So this is 3. M value is obtained. E power minus m. E power minus 3. 1 by e power 3. 1 by 2.7182 whole cube, 1 divided by 2.7182 whole cube. So this is 2.7182 into put it in memory, 1 divided by MRC 0.04979, 0.04979. So you can approximate this to 0.05. You can approximate this to 0.05. Now probability mass function e power minus m into m power r by r factorial 0.05 3 power r by r factorial, where r is taking the values 0, 1, 2, 3, 4 etc. up to infinity. 0, 1, 2, 3, 4 up to infinity. Now you want a probability of x equal to r equal to 0. 0.05 3 power 1 by 3 power 0 divided by 0 factorial. 0.05 into 1 by 1, 0.05. Next, next question. For a Poisson variable, x, probability of x is equal to 1. This is probability of x is equal to 2. Then mean is equal to question mark. Mean is equal to question mark. I have to calculate m value. Mean means m. Now it is a Poisson variable given in the question. This is my probability mass function. So let me substitute here r value 1, e power minus m, m power 1 by 1 factorial, e power minus 1 m square by 2 factorial, m is equal to m square by 2, m is equal to 2, means mean is equal to 2. Fourteenth question, set B. Look at the question. If 1% of an airline's flights suffer a minor equipment failure in an aircraft, what is the probability that there will be exactly 2 such failures in the next 100 flights. So P is equal to probability of happening of an event, What is happening of an event? An airline's flights suffer a minor equipment failure. How much it is given? 0.01. How many flights we have verified? 100. N is equal to number of trials. So M is equal to NP. 100 into 0.01, this is 1. E power minus n, e power minus 1. 1 divided by 2.7182. One divided by 2.7182. 0.36789. 0.36789. So what is required for me? Probability of x equal to r is equal to 2 is question mark. Probability of x is equal to r is equal to 2 question mark. Let me write probability mass function. E power minus m, m power r by r factorial 0.36789 into 1 to the power of r by r factorial, where r is taking the values from 0 to infinity. R is taking the values from 0 to infinity. So probability of x equal to r is equal to 2. 0.36789 1 square by 2 factorial. 0.36789 divided by 2. This is divided by 2. 0.1839. This is 0.1839. This is the answer to the given question. Okay. Question number 15, set B. For a Poisson variable x, probability of x is equal to 2. This is 3 times probability of x is equal to 4. Then variance is equal to question mark. Variance is equal to question mark. So what is your probability mass function? E power minus m into m power r by r factorial, where r is taking the values from 0 to infinity. So e power minus m into m square by 2 factorial, 3 into e power minus m into m power 4 by r factorial. Simply r is replaced with 2 on the left hand side. R is replaced with 4 on the right hand side. E power minus m, e power minus m cancel. 2 will go 12 times, 3 will go 4 times. So 4m square is equal to m power 4. 4 is equal to m square, m is equal to 2. You cannot take plus or minus 2 here. Why? You are calculating variance. Variance is nothing but variance is equal to standard deviation square Variance is equal to standard deviation square. So square of any number cannot be negative. Therefore variance is equal to 2. Variance is equal to 2. Okay. So with this, whatever problems given in the set B for Poisson distribution that I completed. Almost with this, Poisson distribution is over. Okay. Next, I'll go to normal distribution, which I'll take up in the next session. Thank you.